Hey, welcome to the stream. Today, or I guess in this stream, just gonna spend some time planning out my week. I haven't done this in a while, so going to need to kind of catch up on some of the weeks I missed and think about some of the assignments and deadlines I've coming up, and also exams. So, yeah, I was kind of putting this off for a while because I didn't really have that many assignments to do. So I was just kind of going day by day, just trying to figure out what I wanted to do. But now that I'm starting to have a bit more assignments picking up, I think I need to kind of structure my weeks a little bit. So this is Monday, week 6, week 7. Okay. Alright, let's see what we need to do actually. So let's try to create like a to-do list. Checklist. Okay. So I think some things we might need to do. I have Okay, so week 6A write up. 6A. We also have 6B, 7A write up. Maybe I need to do week 1. A, week 2, 1B, A, 1B, 2A, 2B, extra credits. Okay, I think I need to do that. Then also finish CMSC 7.2 project. Seven is equal to A minus. exam 40%. Okay, so, past exams announcements. Ooh, so it's coming up Wednesday, March 13th. Okay. So week 6 will be, okay, we have Monday, March 4th, 2024, Tuesday, March 5th, 2024, Wednesday, March 6th, 2024, Thursday, March 7th, 2024, Friday, March 8th, 2024, Saturday, March 9th, 2024, Sunday, March 10th, 2024. Nice, okay. So we have that. Seven. Okay. Oh man. Oh, I think it's this. Okay, and then week 8. So this will kind of be the halfway point. We also have EMG 726 midterm exam. Midterm in class. Midterm exam. CMSC 472. Alright, so I also have to finish BMGT for 40 assignments. 1. I think it's week 6, so project 2. It's due on Friday. Alright. Great scope. Assignments due March 6th, so this is also due, okay. BMG BUFN 402 assignment 2. Checklist. Okay, so submit. Assignment BUFN 402 assignment. Project 2 due. Okay. So I should probably start studying. This is when my exam is. Tuesday, March 5th, 2025. CMSC 472. Midterm exam. Okay. CM1. Okay, so I got 2 weeks and then I have a bunch of midterms, so I gotta start catching up on maybe some stuff I don't fully understand. Yeah, start creating some flashcards for those. Okay. Then we also have so BMGT 313 summary. Okay, so Monday, February 26, 2024. Study CMSC 472. Okay, actually, yeah, I might not need to do that. Study flashcards. I just do study BUFN 402, BMGT 3, BMGT 6. On BMGT 726 right up. A. Right. Then we also have C472. Right, so lots of flashcards. I think that's probably the best way I'll learn. Did not do these, okay. So 09 a.m. So wake up. 9:30 a.m. We have BMGT for 40, and then 10:30 a.m. Office hours 12 p.m. BMGT 726. 2 p.m. BUFN 402. 3:30 p.m. BMGT 3 p.m. So maybe go for a little walk. 5:30 p.m. Finish CMSC 472 project, and then 7 p.m. dinner. 7:30 p.m. BMGT 726 right up. 9 p.m. Study so Yankee flash cards. 12 a.m. Zang fund if I have time. Oh wait. Boofin 402 project. Right. Go 2 a.m. sleep. Okay. So finish CMSC 472 project. Right. This gives me an hour and a half, hopefully. So finish. Okay. Yeah. So maybe complete question 2, start questions 3 and 4 of BUFN 402 project. Okay, so I think that's a pretty good day. It's pretty good, honestly. Gonna be a lot of work to do. So, yeah, office hours plus lunch. Okay. In the meantime, then, I'm probably going to spend some time. Oh, man. Alright. I'm going to spend some time right now just going over some flashcards. Going over some flashcards for class. Okay. So current classes. Let's study a little bit. What are the two different types of labels in the context of describing data? What type of problem use these labels? What are examples of both? So I think when we think about labels in the context of describing data, usually have continuous or discrete labels. Continuous labels are I think so. So continuous labels could be something like weight, where you have kind of this infinite number of possibilities that a person can weigh an infinite number of combinations or types. And a discrete label is something that is more concrete. It has a finite number of examples. So finite number of examples could be, let's say, a type of car, or maybe the brand of car. There's a finite number of brands of cars: Toyota, Honda. Classifying animals. Okay. What are structure labels? Structure labels are a bit more complex. They are labels that might have, I guess you could say, an object-like or structure to them. I think the most pressing one I could think of is kind of this parse tree that you could use to maybe label data for a natural language processing model, so an NLP model. What is the idea of a norm in the context of linear algebra? What is the L1, L2, Ln norm? So the L1, the L2, and the Ln norm, these are all norms or ways to measure kind of like a length of the vector of a vector. You have L1, this is a measure of Manhattan distance of a vector. L2 norm is measure of Euclidean distance. So Euclidean distance is kind of the idea of taking the direct path within some type of space, I think. Euclidean could also maybe mean in the coordinate space, what's the distance, the most direct distance. Okay. Why is it harder for institutional investors to earn higher returns? This has to do with the fact that large institutional investors have bigger price impact than smaller institutional investors, or just smaller investors in general. This causes them to not be able to really invest in strategies where there might be thinly traded securities, or there's not a lot of volume for a specific type of security. For any constant c, what is the expectation of c? It's just c. The expectation of any constant is just going to be the constant itself, because of the fact that probability is always going to be 100% that your constant is going to be the same. How do we get from variance of x, which is equal to expected value of x minus expectation of x squared, to variance of x plus expectation of x squared minus expectation of x squared? So if you kind of expand this out, you get x minus the expectation of x times x minus the expectation of x. Then you can then distribute these. I think you can distribute each of these terms, so you get x times x squared. Yeah, so it'll be x times x, that's x squared, minus x times expectation of x. Then you have expectation of x times x times expectation of x times expectation of x squared. So, alright, so you'll get something that looks like x squared minus 2 times x times the expectation of x plus expectation of x squared. So then you have that inside these inner expectation. So you have then the expectation of x squared minus the expectation of x times the expectation of x. Sorry, you have 2 times x times the expectation of x. So the expectation of x serves as a constant. The 2 is also a constant, so you can move that out. Then you have 2 times the expectation of x times the expectation of x, which is just 2 times the expectation of x squared, and then you also add the expectation of x squared. So then it becomes negative 2 times the expectation of x squared minus expectation of x, or plus expectation of x squared. Okay, that's a mouthful. Then you finally have the expectation of x squared minus expectation of x squared. Alright. What are important properties of loss functions? I think one important property is that they should be somewhat monotonically increasing, and I think they need to have non-zero values for they need to have non-zero values for mistakes or losses, and they have to have 0 for a correctly classified or correct answer. Okay. How do people usually invest in target date funds? People usually invest in target date funds through their retirement accounts, 401ks. How can we mathematically define the variance of x for any random variable x? How can we put it into words? So the variance of random variable x is just equal to the expectation of x minus the expectation of x squared. So we could think of it as the expected squared deviation of a random variable plus the expected square deviation for a random variable from the average. How can norms be used to find the distance between two vectors? How can it be used to find the length of a vector? So I think when you have the distance between vectors, you're just subtracting two vectors and you can find the norm of that vector. How do you actually find the length of a vector? You can just take the norm of a single vector. Norms and distances are the same. I think maybe all distances are norms, but not all norms are distances. Okay. What is a basic proof for the linearity of expectations for discrete random variables? Man, yeah, this one's hard. I think the underlying idea is I'm just gonna skip this for now, but I think you have a double summation here for discrete random variable. So let's say you have expectation of x plus y that's equal to probability of x is equal to x and y is equal to y times xy times x plus y. And then you sum through all of the possible x's and y's. Okay. It's not too hard. For any constant c and arbitrary function g, what is expectation of c times g of x, y? Expectation of c times g of x is just equal to c times expectation of g of x. Right, so the actual expectation of a constant, that itself is just always going to be the constant. Now our random variable of our function that takes in a random variable, that actual expectation is unknown at the time. And so if you take the expectation of that, it still was some expectation. We're not too sure. I guess you can also distribute it. Okay. What is the linearity of expectations? I think the linearity of expectations has to do with the fact that you can add expected values together. And its property is something, I guess an example kind of shows this property. the expected value of say random variables x and y is equal to expected value of x plus the expected value of y. And it shows that the expectation of the sum of random variables is equal to the individual sum, to the sum of the individual expectations. Okay. CI. So they're just moving the expectation in here. Okay. What is a target date fund? Who offers them? Who uses them? Target date funds are funds that shift their asset allocation as the target date approaches sometime in the future. Who offers them? Big asset managers, Vanguard, BlackRock, and they're commonly used by defined contribution plans, specifically retirees that are part of a plan. What is the null hypothesis? The null hypothesis is some idea that is used in hypothesis testing. So when you're researching or doing an experiment, this is your idea, your thesis, your hypothesis, that there kind of is no relationship between maybe some variables that you're testing, or that maybe some population mean is 0, or this is kind of like your baseline assumption. Okay. What range of values of r squared can be in, or does a high or low r squared mean? So I think r squared could be in a range of values. So range of values could be 1 minus sum of squares. So r squared is 1 minus the sum of square residuals over the total sum of squares. A high r squared means that a model is pretty good, a predictive model or some type of regression to run fits the data well, and a low r squared means that it doesn't fit the data well. How are asset management firms utilizing generative AI? I think Morgan Stanley's using it to support their financial analysts, maybe. JP Morgan's using it for building bespoke portfolios. Right, okay. Why would one prefer using softmax in the multi-class classification setting for discrete labels over regression and one-hot encoding? I think because softmax gives you a probability instead of like an actual label, so when you're using softmax, it might be easier to compare different outputs of a neural network by comparing the probability instead of an actual continuous label. The reason why that is because when you're converting a discrete to a continuous, let's say you're mapping it to numbers, 1 for black, 2 for blue, 3 for red, and you're trying to maybe classify some type of color, then you might notice that there's a similarity or an ordering to the colors even though there isn't, and so that might cause some unwanted behaviors from the neural network. One-hot encoding is also a similar problem where you might have some measure of Yeah, could you one hot encode the labels? Then I feel like you might. I think you might have the same problem, but I'm not entirely sure. Red. What is a good hedge against deflation? Why a good hedge against deflation is a country's or sovereign debts, because it gives you a fixed stream of income, and that stream of income is promised. So if the value, let's say if the dollar declines, but you have some type of bond that gives you, let's say, 5% interest on principal, then you're getting a guaranteed 5% on your principal, and the value of that coupon payment is increasing as long as deflation is also increasing. What is a p-value? What does a high or low p-value mean? P-value, or I think it's called probability value, is a statistical measure of the chance or the probability that our alternative hypothesis is observed if the null hypothesis is true. And so when you have a low p-value, that means that the actual chances of your hypothesis, your alternative hypothesis, happening is pretty low. If you have a high p-value, that means that there's a pretty good chance that your actual alternative hypothesis happens with the null hypothesis being true. So it could just be that your alternative hypothesis just happens. I think the p-value, I want to say it's generated from, I feel like it is generated from the t-statistic. The t-statistic itself is normally distributed, and I think as the number of samples, usually in, let's say an experiment approaches a really high number, then the t-statistic or the t-distribution will approach the kind of population distribution. So I think a t-distribution maybe is just an approximation for an actual normal distribution. Okay. How can norms be used to find the distance between vectors? How can it be used to find the length of a vector? Norms could be used to find the distance between vectors by just taking the difference between two vectors and then finding the norm of that vector. And it can be used to find the length of a vector by just taking the norm of that vector. Norms and distances are not the same, but they're similar. So norms usually measure length. Distance is the length of the vector that connects two different vectors, kind of. What is r squared? What is another name for r squared? I think r squared is just a statistical measure of how well some type of predictive or regression statistical model fits the data. Another name for r squared is the coefficient of determination. How well an independent variable or a collection of independent describes the variance of a dependent variable. Okay. How do we calculate the p-value in hypothesis testing? So the p-value can be calculated when we have some type of, I think, statistical testing. Some common ones are t-tests, and then you also have analysis of variance, and I feel like there's another one I'm missing. So I remember we talked about how the hypothesis and inference testing works in class. I kind of forgot exactly how it's done. I wanted to say that it involves a significance level. So let's say 95%, 90%, I think maybe 99% confidence, 1% significance. So 99% usually is also used to describe a confidence interval, which goes hand in hand with the significance level. So I think the significance level is 1 minus the confidence interval level, and that actual percentage represents the chance, that represents the confidence interval that has a 99% probability of including the true mean of some type of population distribution. T-test, chi-square test. How do we calculate R squared? Online registrar Starmer. So R squared, you have, I think the sum of squared residuals minus the total sum of squares divided by the sum of squared residuals. So it's just 1 minus. I don't know, it would be total sum of squares minus the sum of square residuals over the total sum of squares. Yeah. This is just 1 minus the sum of square residuals over the total sum of squares. X and Y is any predictive model. What is the alternative hypothesis? The alternative hypothesis is kind of this idea in machine learning where, not machine learning, sorry, in hypothesis testing, statistical hypothesis testing, where if you have a null hypothesis and then, okay, let me start, backtrack. My mind's shutting down, so I think it's about time to go to sleep soon after I finish this. But alternative hypothesis is kind of this idea, thesis that you have that you want to test to see if it's true. And this idea usually has the underlying thesis that some type of independent variables might actually have some effect on a dependent variable. It's kind of the alternative hypothesis. Okay, it contradicts the null hypothesis. Okay. Yeah, this is where I don't really remember, but I think that's pretty good. Alright, so I think that's good for this. Yeah, I think that's good for today. I'm probably gonna end the stream here, and I'll see you guys tomorrow. So, good night, sleep well.